Let's do this problem right here. It's asking find the basis and the dimensions for the solution of the system. It's given x plus 3y plus 4c is equal to 0, 2xy plus 3c equal to 0, minus x plus 2y plus c equal to 0. So in this case, if we look at this, if we have a system that is 0, 0, 0, that's basically null space. Because null space means ax is equal to capital 0. It means all of the third values are 0. So when they ask for basis for this kind of question, we have to solve this in terms of null space. So let's do this. Let's see how we can solve this. So first of all, I arrange this into matrix form. So it's going to be 1 3 4. Then second one is going to be 2 1 3. The third one is going to be minus 1 2 1, and at the end we are going to have 0 0 0. Now I have to do the Gauss Jordan to see whether we can whether these three are linearly independent. So let's see. So first of all, to eliminate the third one, I can uh, uh, I have to bring it into 1 0 0 0 1 0 0 0 1. That's the Gauss Jordan pattern, right? So first let's begin with the third column. So if I add this one with the first equation, it will become 0. So let's do this. So it's going to be 1 3 4 0 2 1 3 0, and here we are going to have r1 plus r3, so which is going to give me this one 0, then another one is going to be 5, and if you do that 4 plus 1 it's going to be 5, and we have 0 right here. So let's continue doing this. So in this case 1 3 4 0. So let's move to the second column. So if you want to make this one 0, I can multiply the first equation uh, second row. So I have to multiply by the first row by negative 2 and add it with the second row. So if I do that, it's going to become minus 2 r1 plus r2, which is going to be equal to 0, and this is going to become minus 6 plus 1 is going to be minus 5, and minus 8 plus 3 is going to be minus 5. This is 0, and here we have 0 5 5 0, and now this is obvious that if we add the second row and the third row, one of them will become 0. So let's eliminate one of them. So let's do this. So 1 3 4 0 0 minus 5 minus 5 0, and we have 0 5 5. I can eliminate it by simply adding with the r2 plus r3 is going to be give me this one 0 0 0, and the last one is going to be 0. So let's bring this. We didn't reach the full Gauss Jordan pattern yet. So to do that, I have to 1 3 4. This is going to be 0. Then I had to make this one in a similar form. I can divide it by minus 5. So it's going to become 0 1 1 0. Then according to Gauss Jordan, we have to make the values above or below the pivots is equal to 0. So in this case, I have to make this one equal to 0. So to do that, I have to multiply the second equation by minus 3 and add it with the first equation. So let's see what happens if I do that. Uh, so it's going to be, I am multiplying the second equation by negative 3. So negative 3 r2 plus r1, which is going to give me 1 0. Then we have minus 3 plus 4 is going to be 1. That's going to give me 0 right here, and we are going to have 0 1 1 0 in the second row. Now we have reached the final Gauss Jordan pattern, and in this case, if you see, this one has pivot, this one has pivot, this one has pivot, but the third column doesn't have pivot. Therefore, third column is my free variable. And if you say this is x y z, z is going to be my free variable. So therefore, z is free variable. So we had to solve everything. We had to give everything in terms of free variable. So let's form the equations according to this one. The first equation is going to be x plus c is equal to 0. The second equation is going to be y plus z is equal to 0. Then from this one I can find the x is equal to minus z, y is equal to minus z. So we have to write the answer in terms of free variable. So therefore x y z is going to be minus c minus c, z is going to be z. So this is not the final answer, but because c can be any real number, right? So we don't want the situation. We want the simplest form when they ask for basis. So in this case, what we have to do is we have to take the c command. So if we take the c command, this will become minus 1 1, and whenever we want to give the answer basis, answer in a basis, we have to give v is equal to, we should eliminate the c completely, because c is gonna make this one into infinitely many variables, so we don't want that, we want a simple form. So in this case the final answer is going to be minus 1 minus 1 1. And from this one we can decide what is the dimensions of the dimension of this span. So the dimension is going to be depending on the free variable. So if you have one free variable, the dimension is going to be 1. So in this case we only have one free variable, therefore this is dimension 1. So that's the answer for this question. And let's move to the second question. They are asking find the basis and the dimensions for span 1 1 2 3 minus 0 4 0 2. So let's see how we can do this. But this is totally different. In this case they didn't equalize to 0, so we don't have to worry about null space in this case. So to do this one, what I can do is I can simply arrange it in rows. For example, this is going to be 1 1 2 3 minus 1 0 4 0 2, and now I have to do the Gauss Jordan. So if I do the Gauss Jordan, what's going to happen is 1 1 2, I can do both of them together. Let's do this. Let's do both of them together. So to eliminate the first one, to make this one equal to 0, I can multiply the first equation by negative 3 and add it with the second equation. So it's going to be negative 3 r1 plus r2, and the minus 3 plus 3 is going to be 0. Then we have minus 3 plus minus 1 is going to be minus 3 plus minus 1 is going to be minus 4. Then we have minus 3 times 2 is going to be minus 6 plus 6 is going to be minus 6. Then the third row we have my 4, so let's do this one. To eliminate this one, I can multiply the first equation by minus 4 and add it to the third equation. So it's going to be minus 4 r1 plus r2. This will give me 0 right here, and if I multiply this one by minus 4, this is going to be minus 4, and if I multiply this one by minus 4, it's going to be minus 8 plus 2 is going to be minus 6. Now from this one, it's very obvious that we can eliminate one of them by simply multiplying by negative 1 and adding them together, right? So this is going to be something like, so let's do this one. So 1.2, so if I put the second one as it is, so 0 minus 4 minus 6, and if I multiply the second equation by negative and add it with the third equation, let's see what happens. So r2 negative r2 plus r3, which is going to give me 0 0 0. Therefore we know this is not a linearly independent vector, so we eliminated one of them. Now we are not done yet, we have to bring this one into full Gauss Jordan pattern. So in order to do that, I have to make it a little bit simpler. So if I make this one simpler, what will I get? So to do this, to make this one simpler, I can simply divide this one by negative 4 to make this equal to 1. So if I divide this one by negative 4, I will get 1, and this is going to become 3 by 2. And we are not done. uh, Now we have to make whatever the values above the p was equal to 0. In this case we have 1 right here, so I can eliminate it by simply multiplying the second equation by negative 1 and add it with the first equation. So let's do this. Minus r2 plus r1, which is going to give me 1 0, and this is going to be minus 3 by 2 and plus 2. So plus 2 is going to, we can write it as 4 by 2, and 4 by 2 minus 3 by 2 is going to be 1 by 2. And the second one is going to be 0 1 3 by 2. So from this one we know that we have two linearly independent variables, therefore these two are going to be my basis. So b is equal to, from this one we can select the row that has pivots. So in this case we have the rows 1 1 2 and 3 minus 1 0 is the rows that have pivots, therefore I put this one as a basis. So this is going to be 1 1 1 2 and 3 minus 1 0. That is my basis, and they are also asking for dimension. To find the dimension, it depends on the how many linearly independent vectors we have in this one. So after we solve this Gauss Jordan, we know we have only two linearly independent vectors, therefore the dimension is equal to 2. So this is how we approach this kind of questions, and I hope you guys like this video. See you next time.